Hi class, here's the homework for 7.3 homework for, the date is 2/20. I'd like to put the date on there. Okay, so the first three questions are from our notes today, or you can find them on page 478 or 479 in the book. And you can write these out. These are theorems. Are the triangles similar in each pair? So we're going to use either AA, SSS, or SAS. And if they are similar, then we're going to write the similarity statement. So in question number 4, we have two triangles, and this angle here is congruent to this angle here, since they have the same measure. And this angle here is congruent to this angle here, since they have the same measure. So look at that. We have an angle and an angle for each of these triangles. So these two triangles are similar by AA. Angle, angle. And the similarity statement then would be triangle ABC is similar to triangle, see, ABC is similar to triangle D, because those are the corresponding angles, E, and then F, because F and C are corresponding. Okay, number 5. I don't have any angles measured here, but we do have sides, and corresponding sides need to be proportional. And if all three of those sides are proportional, then we will have a set of similar triangles. Well, let's look at all three sides. Now remember, when you look at these two triangles, the biggest side is opposite the biggest angle. So we'll look at 35, and this is the biggest side, and that's opposite the biggest angle. So we'll look at these two sides. These two sides are corresponding. So 35 to 28. Okay. Now, does that equal, the medium size here is 25, and that corresponds with 30. So I'm going to, because I went from big to small, I'm going to write 30 on top to 25. Maybe I could use different colors. That might help a little bit. So 30 and 25 are corresponding sides. And then the last pair of corresponding sides is 32 to 24. So I will write 32 to 24 here. Okay, now, those are all the ratios of the corresponding sides. Now, are they all equal to each other? Well, if we simplify them, they might be. Ways you can do this. When you simplify these ratios, you can look for the common factors. So this one has a common factor of 7. So that is, divided by 7 is 5, divided by 7 is 4. So this first one can be simplified to 5 over 4. Now if I look for a common factor here, I know 5 goes into both of these. So 5 goes into 36, and 5 goes into 25, 5. So now I'm seeing that these are not going to be similar, because look, already the ratios are not the same. But let's just check the last one. If I divide that by 8, that's going to be 4 over 3. Okay, so none of these ratios are the same. Another way you can do it is I could take 35 and divide it by 28, and I get a decimal of 1.25. And I can see if that is equal to 30 divided by 25, and that is 1.2, and I can, these are not equal, right? They're not equal. So I guess I could put a question mark on these. We don't know if these ratios are going to be equal. And the last one is 32 divided by 24. And so that's 1.333 continuously. So these are not. So this is no. These are not similar, because their sides do not correspond. They're not proportional. The corresponding sides are not proportional. Okay, let's look at number 6. We have a side, an angle, and a side. So we're going to see if we can prove it with side, angle, side. Side, angle, side, side, angle, side. Well, in order for this to be similar by side, angle, side, the sides have to be proportional, the corresponding sides. So this 8 corresponds with 6. Now, is that equal to 20 to 15? So I put 8 with 6, because those are corresponding, and then I put 20 to 15. All right, so if we simplify those, let's see if those are the same ratio. So if I divide this by 2, I get 4 over 3. And if I divide this by 5, right, top and bottom, I get, 4 over 3. So these sides are proportional, and they have an angle in between them. So these are similar by side, and then the angle in between them, and then the side, because their sides are proportional. Now we write the similarity statement. So triangle, I'll start with K. KLJ is similar to triangle NPM. Be careful when you write your similarity statement that the corresponding angles are listed in order. K with N, L with P, J with M. Okay. Are these two triangles similar? Well, we have an angle here and an angle here. We don't have any side measurements. So we're not going to use SSS or SAS most likely. We can use AA though. Let's see if we have two angles. Well, we have this angle and this angle are similar. And remember why these two angles would be similar? They're vertical. So we have angle and an angle and an angle and an angle. So these are similar by angle, angle. And our similarity statement would be triangle, let's start with VXW is similar to triangle, so VXW is similar to triangle YXZ. Be careful how you write your similarity statements. Make sure the angles are in the right order. V is congruent to Y, X is congruent to X, and W is congruent to Z. Okay, number 8, I see we have sides listed here. We have 3 sides here and 3 sides here. So let's try to see if this is true, or excuse me, if these are similar by side, side, side. So could side, side, side work? Well, we have to set up our ratios to see if they are congruent. So it looks to me like we can put 3 with 6, the small sides, the smallest one here and the smallest one here. And then we have 4 with 8. And then we have 5 with 10. Notice I'm always going the same direction. I'm going from 3 to 6, 4 to 8, and 5 to 10. And now I'm going to see if I can simplify these and if they are going to be congruent. Well, this can be changed to 1/2. If I divide top and bottom by 3, divide top and bottom by 4, I get 1/2. Divide top and bottom by 5, I get 1/2. So all these ratios are the same. So this triangle is similar to this triangle. So yes, these are similar by side, 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 since all the sides are proportional. And then we can write our similarity statement. Triangle PQR is similar to, now you go ahead and write what that's similar to. PQR is similar to what triangle? And you go ahead and write your 3 letters there. Okay, number 9. I see sides given here, so this side and then this long side. See how there's 2 triangles here? We have a smaller triangle and a larger triangle. So we have a shorter side here and then the long side here of this triangle. Then we have this side for the smaller triangle and then this side for the larger triangle. So we have 2 sides. We don't have the third side, but we do have an angle because in here they share an angle. So we have a side, angle, side, posse if side, angle, side will work. Okay, so I need to see if, I see that they share the angle, but let's see if their sides are proportional. So I put 15, I'm going to put the small side here, 15 to the long side. So the short side of this, the side of this smaller triangle compared to the side of this larger triangle, is that equal to the side of this smaller triangle compared to the side of this longer one? Those are the corresponding sides. This one corresponds with this longer one, and this side corresponds with this longer one. All right, can this be simplified? And now you could use your calculator as well. Remember, you can simplify these. Okay, I could divide these by 5 and divide these by 5, and I get 3 over 5. And if I divide this by 3, I get 4. If I divide this by 3, I get 7. And notice these 2 are not equal, so these are not similar. And I was going to mention you can use your calculator, so I could take 15 divided by 25, oops, 15 divided by 25, and that's 0.6. Is that equal to 12 divided by 21? 12 divided by 21. I did it again. And I get 0.57. So no, these are not equal. So the sides are not proportional, so we cannot use SAS. Okay, number 10. Are these triangles similar? Well, let's notice a few things here. This side and this side are congruent, right? And notice the same thing happens here. This side and this side are congruent to each other. Okay. Well, if this side and this side are congruent, this is an isosceles triangle, so this angle is going to be congruent to that angle. Right? These are base angles of an isosceles triangle. And if we go over to this triangle, we also have an isosceles triangle. So these two angles are also base angles. So it turns out that this triangle here is going to be similar to this triangle because they have two angles that they share that are congruent. This angle and this angle are congruent, and this one and this one. So these are similar by angle, angle. And you can't give a similarity statement here because I forgot to put letters on here. So we're just going to say they're similar by AA. Okay? Number 11, can you find the scale factors in the figures in number 8? So let's go over to number 8. And we need to find the scale factor. And it says, give both answers. So what that means is we need to find the ratio or the scale factor from the small one to the, and then from the big triangle to the small triangle. So from the small to the big, remember these are corresponding sides, 3 and 6. So we can use 3 and 6. So over here, I'm going to say 3 and 6. That's the scale factor from small to big. And then the scale factor from big to small would be the other direction, 6 to 3. Okay, so the scale factor from small to big is 1/2, and the scale factor from big to small is 2/1 or 2. Remember, the scale factor is just a fraction. It's just a ratio of one pair of corresponding sides. If we're going to, see if I can zoom in a little. If we're going to use proportions to solve, we're told that these two triangles are similar. Actually, I didn't say that, so let's do that. These are similar triangles. Okay, all of these are similar triangles from numbers 12 to 16. I forgot to say that. Okay, so AB is 8, BC is 4, DF is 6, and EF is 12. So I labeled my sides. And I want to solve for AC, let's call that X, and DE, let's call that Y. I need to solve for X and solve for Y. All right, well, first I need to set up my proportion using the scale factor. So the scale factor here, I have this side and this side I could use, or this side, no, just this side and this side are the only ones I know right now. So I'm going to use 8 and 6. 8 and 6 are the corresponding sides. So 8 to 6 is our ratio. And I'm just noticing also that this should be smaller than this one. That's okay. It's not drawn to scale, unfortunately. Okay, so 8 to 6 is going to be equal to, let's find another pair. Let's solve for X. X to 12. So 8 to 6 as X is to 12. See what I did there? This corresponding pair of sides, I know that ratio, but I don't know what this ratio is because we don't know what X is. So because these are similar, I can set them equal to each other. So this is 8 times 12 and 6 times X. So that is 96 equals 9. 96 equals 6x, so x equals 16. Now we need to find y, so we'll use the same pair of corresponding sides. 8 goes to 6 as 4 goes to y. These are the corresponding sides we need to use now. 4 goes to y. So that's 8y equals 24. And divide by 8 and we get y equals 3. Okay, number 13. If mn equals 6 and no equals 9, po equals 12, and qo equals 15, find mo, let's call that x, and let's find pq, let's call that y. So we need to find x and we need to find y. So we need to set up a proportion. And solve. So a pair of sides that we know for sure that our corresponding sides are 9 and 12. We know those two numbers for sure. So this side corresponds with this side. So I'm going to put 9 with 12. And then I'm going to put x with 15. And I can solve that proportion. And you go ahead and solve that for x. Then the other proportion I would use to solve for y is I would still use these corresponding sides, 9 is to 12, as 6 is to y. And now you solve that for y using cross multiplying. Okay, number 14, find x and y. Again, we're going to set up a proportion. These are all similar. So we're going to set the sides that we know. Now be careful, this figure needs to be flipped over to show you what sides are corresponding. So it looks like 6 corresponds with 4. So I'm going to go from the big to the small. So this side right here corresponds with this side. 6 corresponds to 4 as 10 corresponds to y. And now you solve for y by cross multiplying and solve for y. And then we're going to use the ratio again of 6 to 4, those corresponding sides. And now we're solving for x, 8 to x. And solve that one. Now I believe these are going to be fractions, so let me just see what happens here for this one. We get 6x equals 32, so x equals 6, and then we have to simplify that. I can divide that by 2, that's 16 over 3. So you get 16 thirds, or if you put it into a calculator, which I'm fine with just writing it like that, you get 5.33 with a bar over it. And I think you're going to get a fraction for this one as well. Okay, number 15. Now these triangles are nestled inside of each other, so as we write our proportions, we need to remember that. So I see that 3 corresponds with 5. I'm going from smaller to larger. And that means that 9 corresponds with x. Okay? So this is a triangle here, a smaller triangle, and this is a larger triangle. So I put the smaller side, I put the side from the smaller triangle to the same corresponding side of the larger triangle, 3 to 5. And then 9 corresponds with x. And solve that. And that is not going to be a fraction. Okay, 16. Find x and y. Again, we're setting a proportion. These angles are congruent. Remember, they're vertical. So my proportion is going to be 6 goes to 4 as, now I started with this triangle, so I'll start with this triangle, as x goes to 5. Okay, we cross multiply to solve, and we get 4x equals 30. And then we divide by 4, and we get x equals 30 over 4. And we can simplify that to 15 over 2. Okay. And then to solve for y, we'll use this same pair. 6 goes to 4, this triangle to this triangle, as 7 goes to y. And then you can cross multiply again and solve, and you'll get another fraction. Okay. Number 17, the ratio of 2 supplementary angles is 7 to 5. Find the angles. So you take 7 and multiply it by x, and you take 5 and multiply it by x. So that's going to be your new ratio. Well, these two angles are supplementary, so they have to add up to 180. And now you solve for x, and you're going to get x equals, I think, 15. So go ahead and do the math there. And then to find each angle, I just take 7 times 15. So 7 times 15 equals 105. And then I take 5 times 15, and I get 75. And there's my two angles. And look, if I add them up, they add up to 180. They're supplementary. Okay, number 18, last one. The diagonals are a rhombus, so I'm going to draw a rhombus. And these diagonals here, one of them is 12 and one of them is 16. And I want to find the perimeter. That means I need to find the length of the sides. Well, you need to remember all the sides are the same length, right? And the diagonals bisect each other. So if one of them is 12, then this is 6 and this is 6, right? This length, let's say this one is 12, so they're cut in half. This diagonal is 16, so it's cut in half. And now I have all my diagonals, all the diagonal pieces. This one's 12, this one's 16, but they're cut in half. And we know all the sides are the same length, and we also know that these diagonals meet at a 90-degree angle. So if I want to find the length, if I want to find the perimeter, I need to find the length of the side, and then they're all going to be the same, and I add them all up together. How do I find the length of the side? Well, I'm going to use the Pythagorean theorem. 6 squared plus 8 squared equals, let's call it c squared. Okay, so we've written the Pythagorean theorem here using this side. This is a leg. This is a leg. They both form this 90-degree angle. Okay, so these are legs. So we're solving for the hypotenuse. So that comes over here. So we have 36 plus 64 equals c squared. That's 100 equals c squared. To get the c by itself, why not c, right? Take the square root of both sides. We get 10 equals c. So the length of this side is 10. So if the length of this side of the rhombus is 10, then the length of all 4 sides are each 10. These are 4. Excuse me, these are 10, these are 10, this is 10. So there's 4 of them. The perimeter is going to be 10 plus 10 plus 10 plus 10. So the perimeter is 10 plus 10 plus 10 plus 10, 40. And that's the lesson for today.